Welcome to a new unit of Python Fundamentals. In this unit, we'll learn how to move shapes on the screen. Let's get started. In Unit 7, we learned how to provide inputs to our programs using the input function. Quite similar to that, we can also write functions that take more granular input, the pressing and releasing of a keyboard key. This type of input is quite useful when you're building animations and games. Sound exciting? Let's learn it using an example. If you look at the code we have, you'll find three functions. The first one is key down, which takes a key as a parameter and prints a line. The second one, key up, is also very similar, except the print statement's a little different. The third function, draw frame, uses a pass statement, which means that it does nothing. Finally, we have the start graphics function call. Now, we have seen this function in the last unit, except this time it seems to take very different arguments. The two important parameters to note are key press and key release. While we pass key down as a value of key press, we pass key up in key release. When we run this program, we see a graphics window. And as you type on the keyboard, for each letter type, it prints two lines in the console. One on key press, the other one on key release. This shows your program calls the key down function on key press and the key up function on key release. Please go ahead and pause your video. Try this example on REPL yourself. Oh, in case you face any issues, don't hesitate to ask for help. Let's move on and learn how to provide input via the mouse. If you look at this example, you'll see there's a function called clicked. This function takes x and y as parameters. Can you guess what x and y really are? Yes, they are the coordinates on the screen of the mouse when it is clicked. We also have a main function that does nothing but clear the screen. Finally, we call start graphics with mouse press as a parameter as clicked. Try this out in your REPL IDE before we move on to the next example. In this example, we again have a function named clicked. It takes two parameters, mx and my. Remember, they denote the coordinates of the mouse where it is clicked. We also have a function called graphics that draws a circle with x and y as its center and 50 as its radius. It does so only when the value of the drawn variable is true. Now x, y, and drawn are three global variables, and we use them to coordinate, no pun intended, between the two functions, graphics and clicked. We also set the initial values of x as 0, y as 0, and drawn as false. Let's dig deeper and understand this better. So inside the clicked function, we use the global keyword to tell our program that x, y, and drawn have global scope and are not local variables to the function. Now, when a user clicks on the graphics window, the clicked function is called. In this function, we set the value of drawn as true and the value of x and y as mx and my respectively. Graphics functions use these global variables modified by the clicked function, essentially drawing a circle of radius 50 at the place you clicked your mouse. Please do try this in your REPL IDE. It'll help you understand the concept better. Oh, and remember to ask for help if you need it. You might have noticed that in the start graphics call, we use mouse press as the name of the parameter. This behaves very similarly to the key press parameter, except it tracks mouse button presses instead of keyboard key presses. There are two more mouse-related parameters that you can use. One of them is called mouse release. This one behaves very similarly to the key release parameter. There's another parameter called mouse move, and it can be used to associate a function with the movement of the mouse. This is a good time for us to learn about how to move objects using CS1lib in Python. All right, So how do we do that? How do we move an object? We essentially update the screen with the updated position of the object. In our main function that is supplied to start graphics, if we change an object's x and y coordinates, the object will be placed there in the next frame. And because frames change quickly, the object would seem to be moving. Let's go ahead and visualize it with a square. Let's first create two variables called xx and yy that we can use in our main function. These will be global variables. We will assign the value of 0 to both of them. Now, inside a function named main, we'll first add a line global xx, yy to indicate that xx and yy are global in scope. We will then clear our view using the clear function. After that, we'll set a fill color. In this example, we're using red, by providing 1 for the red parameter and 0 for both the green and blue parameters. But you can provide whatever color you want. Then, we draw a square. Remember, in the case of a square, the width and height are equal, so we'll provide the same value for width and height. Let's say 20. For x and y values, we'll choose to provide xx and yy. After our function named main, we call start graphics and provide main as an argument to it. Now, when we try to move the square, it works! Start graphics calls the main function for each frame. What this means is that with each frame, the old square will be cleared and a new one will be created 1 pixel to the right. If our program is wanting 24 frames per second, the value of xx is going to be incremented 24 times, and our square will move by 24 pixels in a second. That's pretty amazing, right? Go ahead and try this by yourself. Now that we have learned how to move the square in one direction, let's learn how to move it in the opposite direction. Let's create a Boolean variable called forward and set its value to true. When the value of forward is true, we'll move the square from left to the right of the screen. We'll do that by incrementing the value of xx by 1. Once it reaches the far right of the screen, we'll set the value of forward as false. Now, using this Boolean variable, we'll move our square from the right to the left of the screen. We will achieve this by decreasing the value of xx by 1. Go ahead, look at the code and try it by yourself in your Replit IDE. If you look at the code closely, you probably have a couple of questions. Let's answer them one by one. The first one might be, why do we check if xx is greater than or equal to 400 minus 20? Where did 420 come from? The answer to that is that our graphic screen is 400 pixels wide, and our square is 20 pixels in width. So, to know whether the square has reached the end of the screen, we'll see if the xx value is greater than 380. Remember, a rectangle is drawn from the left side of the screen. The second question you might have is, why do we use an if condition instead of using else to switch the value of forward? The answer to that is if we use an else, the value of forward will be set to true as soon as xx reaches 380. That will technically stop the movement of the square at that point. What we want is a continuous movement of square from left to right and right to left. This is the reason we can't use the else statement, although we could have used an elif statement. Alright, we've reached the end of this unit and made a lot of progress. While this topic seems a bit tricky, I'm sure trying the code yourself and playing with different argument values will bring more clarity to you. We'll see you in the next unit, in which we'll be putting these concepts to use by creating a simple ping pong game.